There are five main issues affecting palm oil biodiesel production in Malaysia. Firstly, feedstock supply is inconsistent due to competition from other industries such as food, oleochemical, and export sectors, which leads to unstable production. Secondly, high production cost occurs because crude palm oil is the main input, and when the CPO prices increase, biodiesel become less competitive compared to petroleum diesel. Thirdly, there are technology efficiency gaps among biodiesel plants. Some facilities still have low conversion efficiency, resulting in higher costs and lower output. Fourthly, logistic and supply chain issues arise due to depressed plantations, high transportation costs, and limited storage facilities which reduce production efficiency. Lastly, policy and market uncertainty, including slow implementation of B10 and B20 programs and fluctuating global prices, creates challenge for long-term planning.
Hi, my name is Siti Fatima binti Mama Azli. My metric number is 298016, and I will present our research framework of Malaysian palm biodiesel sector. So first, let's see research objective. The first research objective is to analyze the current conditions of supply side factors in the Malaysia palm oil sector in relation to palm biodiesel productions. Second research objective is to identify the key supply side variables that are significantly influenced by changes in palm biodiesel productions in Malaysia. Third research objective is to evaluate the impact of palm biodiesel production on supply side performance, particularly in terms of feedstock availability, production costs, technological efficiency, logistic, and policy implementation. So for the last research objective is to assess potential strategies and opportunities for improving supply side performance in response to changes in palm biodiesel productions. So for the research questions, the first research questions is what is the current conditions of the key supply side factors associated with palm biodiesel productions in Malaysia? For the second research questions is which supply side variables are more significantly affected by changes in palm biodiesel productions in Malaysia? For the third research questions is how does palm biodiesel production influence feedstock availability, production cost, technological efficiency, logistic, and policy implementations within the Malaysian palm oil sector? And for the last research questions is what strategies can be implemented to enhance supply side performance in response to changes in palm biodiesel productions. So now the method. For the first method is secondary data analysis by reviewing data from MBOB, government publications, academic journals, and industry reports to analyze the current conditions of supply side factors. For the second method is time series econometric analysis by identifying significant supply side variables using econometric models such as ARDL, VAR, or VECM. For the third method is econometric modeling by estimating the short-run and long-run effects of biodiesel productions on selected supply-side indicators using ARDL, VAR, or VCCM. And the last method is empirical finding and policy analysis by interpreting econometric results and secondary evidence to propose strategies for improving supply-side performance. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Sadan Saufi bin Saiful Shafiq and my number matrix is 303934, and today I will be explaining about the stationary test, the findings and the graph. Moving forward, to establish a clear foundation for our study, we identified three critical research gaps in the existing literature that this project aims to address. First, when looking at past literature, we found that most previous studies tend to focus on general biodiesel rather broadly, rather than specifically narrowing down on the unique context of palm biodiesel here in Malaysia. Given our position as a major palm oil producer, this specific focus is a crucial missing piece. Second, while existing studies do a great job discussing the overall potential of palm biofuel, they often stop there. There is noticeable lack of deep analysis regarding the practical, real-world implementation challenges that industries face when trying to adopt this solution. Finally, previous research, there has been very limited integration of environmental, economic, and technological perspective combined. Our study bridged this gap by merging these three dimensions into a single cohesive analysis.
Okay, hi, my name is Nurul Aida, number matric 298260. I will start with the theoretical framework. Okay, this study explains how supply side factor affect palm biodiesel production in Malaysia. Okay, palm biodiesel production depend on several key input, which are feedback stock availability, production cost, technology efficiency, logistic and supply chain, and policy implementation. Since palm biodiesel is mainly produced from crude palm oil, any change in CPO supply will directly affect biodiesel output. Stable feedstock supply, efficient technology, effective logistics, and strong policy support can increase production. However, high production costs and weak logistics may reduce biodiesel production performance. Okay, next is the conceptual framework. The dependent variable is palm biodiesel production output, which is measured by palm methyl ester or PME in tonnes. The independent variable are feedstock availability, production cost, technology efficiency, logistic or trend, and policy implementation. Okay, feedback availability include CPO supply, fresh fruit bunch production, and palm oil stock level. Production costs include CPO cost, processing cost, and operation and maintenance cost. Technology efficiency refers to transesterification efficiency and conversion rate. Logistics include transportation, storage facility, and supply chain system. Policy implementation include B10 and B20 subsidy and government regulation. Overall, feedstock availability, technology efficiency, logistics, and policy are expected to have a positive effect on production, while production cost is expected to have a negative effect. Okay, next is the model specification. The study used an econometric model to analyze the relationship between palm biodiesel production and supply side factor. The functional form of the model is y equal to function of x1, x2, x3, x4, and x5, where y is palm biodiesel production output, x1 is feedstock availability, x2 is production cost, x3 is technology efficiency, x4 is logistic or trend, and x5 is policy implementation. Okay, next is the econometric model. The model is specified as PBD equal to beta 0 plus beta 1 FA, beta 2 PC, beta 3 TE, beta 4 LOG, beta 5 POL plus error term, where PBD is palm biodiesel production output, FA is feedstock availability, PC is production cost, TE is technology efficiency, LOG is logistic or trend, POL is policy implementation, and result is the error term. This study also used the ARDL model because it allows us to analyze both short-run and long-run relationship between variables. ARDL is suitable for time series data, where variable can be stationary at level 1, 0 or first different 1, 1.
Let's begin with stationary test. Table represents the result of ADF and PP unit root tests for available variables in study, namely biodiesel output, EFB, technology, tech, and demand. At the level form, all variables have test statistics ranging from approximately negative 1.49 to negative 1.84, which are not significant. This indicates that all variables are non-stationary at levels and contain a unit root. However, after taking the first difference, the ADF and PP test statistics become highly significant for all variables, with value ranging from about negative 4 to negative 5 and significant at the 1% level as indicated by the 3 asterisks. For example, biodiesel output recorded an ADF statistic of negative 5.24 and PP statistic, the first differencing. Similarly, EFB, technology, and demand also become statistically significant after first differencing. Therefore, all variables are integrated of order 1, denoted as I1, meaning that they become a stationary only after being different ones. Both of the tables present the estimation result of the log linear model. The regression result indicate that the model is statistically significant as a whole, with an F statistic of 11.8 and probability value of 0.02, suggesting that independent variables jointly explain variations in biodiesel production. The coefficient of determination, which is R square, is 0.7538, indicating that approximately 75.38 of the biodiesel production can be explained by changes in FB, supply, technology, demand, and at the time trend. The adjusted R square value of 0.6882 model suggests that model possesses reasonably good explanatory power. However, the individual coefficient EFB, tech, demand, and trend are statistically insignificant at the 5% significant level, as all p-values exceed 0.05. This finding implies that although the explanatory variable jointly influenced by this production, the individual effects cannot be statistically distinguished in the log transform model. Furthermore, the Durbin-Watson statistic is 1.903, which is close to the benchmark value of 2.0. This indicates the absence of serious autocorrelation among the residuals and suggests that the regression assumptions are reasonably satisfied. Compared with the original linear model, the log transform model exhibits a slight decline in explanatory power, with R squared decreasing from 0.875 to 0.75. In the linear model, EFB, PKS, and technology were found to be statistically significant determinants of biodiesel production, whereas none of the explanatory variables remain individually significant after log transformation. This result suggests that the relationship between biodiesel production and its determinant may be better represented by the original linear specification. Nevertheless, the logarithm transformation remains useful because it improves the statistical properties of the data and enables the interpretation of relationship in percentage terms. The graph shows that biodiesel production in Malaysia demonstrates a generally increasing trend between 2006 and 2025, despite experiencing several fluctuations. Production increased from approximately 15,000 tons in 2006 to around 19,000 tons in 2025. The highest production level was recorded in 2019, while significant declines were observed in 2016 and 2021. The overall upward movement suggests that Malaysia's biodiesel industry expanded over the study period. A significant contraction in biodiesel production was observed in 2016 as output reduced from approximately 19,000 tons to the previous year to around 17,000 tons. This reduction is largely associated with volatile fluctuations in feedstock availability alongside shifting crude palm oil CPO prices. A production decline occurred between 2020 and 21 when output fell from approximately 19,000 to below 18,000 tons. This reduce can be primarily attributed to global economic disruption triggered by the COVID-19 pandemic. The crisis is severely impacted key industrial activities, fractured international supply chains, restricted labor availability.
The finding of this study show that supply-side factors significantly influence palm biodiesel production in Malaysia. Based on the ARDR result, the main drivers of production are technology efficiency, demand, feedstock availability, and market trends. Technology efficiency has the strongest positive impact, meaning that better processing technology increases biodiesel output. Feedstock availability also has a positive effect, showing that a stable supply of crude palm oil ensures continuous production. In addition, demand has a strong positive relationship with production, indicating that higher market demand leads to higher biodiesel output. However, the trend variable shows a negative effect, which reflects instability due to policy change and market fluctuation. Overall, the finding confirmed that technology efficiency and feedstock availability are the key determinants of palm biodiesel production in Malaysia.
In conclusion, this study found that all variables become stationary after the first referencing, which means they are integrated of order 1. Because of this, the ARDL model is suitable to analyze the relationship between palm biodiesel production and the selected supply side factor. The findings show that the supply side factor have an important effect on palm biodiesel production in Malaysia. So technology efficiency, feedstock availability, and demand condition have positive effect on production. This means that better processing technology, stable crude palm oil supply, and stronger market demand can help increase biodiesel output. However, this study also shows that production is still unstable over time due to factors such as policy change, crude palm oil price fluctuations, and market uncertainty. Therefore, to improve the palm biodiesel industry, Malaysia needs to strengthen technology efficiency, ensure consistent feedstock supply, improve logistics, and maintain stable policy support. So overall, the study concludes that supply side improvement is important to support sustainable and competitive palm biodiesel production in Malaysia.
And the next is recommendation section. Okay, based on the finding of this study, several recommendations are proposed to improve palm biodiesel production in Malaysia by strengthening supply side factor. First, for feedstock availability, there is a need to improve the stability of crude palm oil supply. Coordination between palm oil producer and biodiesel plant should be strengthened to ensure a consistent supply of raw material. In addition, during period of high palm oil stock, priority allocation for biodiesel production can help reduce dependency on export demand fluctuation. Second, for technology efficiency, biodiesel processing plant should be upgraded with modern automated technologies. Improved certification system can increase conversion efficiency, reduce production losses, and enhance overall productivity in the industry. Third, for the production cost, target subsidies or cost stabilization mechanism can be introduced to reduce financial pressure on producer. Since crude palm oil price is the main factor affecting production costs, improving operational efficiency can also help reduce overall expenses. Fourth, for logistics and supply chain, improvement in transportation system and storage facilities are needed. A more efficient and integrated supply chain can reduce delay, lower operational costs, and ensure smoother production process. Lastly, for policy implementation, enforcement of biodiesel blending programs such as B10 and B20 is important. A clear and consistent long-term policy direction will help increase market confidence and support higher biodiesel production. Okay, in conclusion, improving feedstock management, technology, cost control, logistics, and policy consistency is essential to ensure sustainability and stable palm biodiesel production in Malaysia.